NEC Section 110.10 necessitates that electrical equipment be adequately rated for the available fault current at its installation point. This requirement spans across all types of electrical equipment, including utilization equipment such as refrigeration units. UL listing signifies that equipment adheres to specific safety standards. However, it doesn't automatically mean the equipment has a defined fault current rating. Underwriters Laboratories, also known as UL, doesn't mandate manufacturers to specify fault current withstand ratings unless the equipment is specifically designed as fault tolerant or fault protected. An authority having jurisdictions, also known as AHJ, interpretation of NEC Section 110.10 demanding a 5 KIC assumed fault current rating for refrigeration equipment might be considered overly conservative. The code doesn't specify a particular fault current rating but mandates that the equipment be rated for the available fault current. Providing overcurrent protection devices rated for the available fault current, such as 22 KIC, doesn't automatically guarantee the refrigeration equipment will withstand a fault current of that magnitude. Series rating dictates that all overcurrent protection devices in series with the equipment must have an interrupting rate equal to or greater than the available fault current. However, without a specific withstand rating for the refrigeration equipment, it can't be presumed it will withstand the available fault current. This interpretation by the AHJ could extend to other equipment, including switches, contactors, motor starters, and elevators. However, these items typically lack fault current withstand ratings. Therefore, imposing a requirement for them to withstand the maximum available fault current is often impractical. In summary, the AHJ interpretation of NEC Section 110.10, mandating a 5 KIC assumed fault current rating for refrigeration equipment, isn't supported by the code or industry standards. Providing main and feeder or overcurrent protection devices rated for the available fault current of 22 KIC generally meets the requirements outlined in NEC Section 110.10. It is recommended to engage with the AHJ to clarify equipment withstand rating limitations and the practicality of series ratings. If the AHJ remains unconvinced, consider additional protection measures like arc flash relays or current limiting fuses. Contact the refrigeration equipment manufacturer to confirm adherence to all other safety standards and discuss potential fault current risks. When dealing with electrical installations, several critical factors need careful consideration to ensure safety and compliance with the National Electrical Code, known as NEC. Firstly, it is essential to accurately calculate the available fault current at the point of termination to the equipment. This calculation forms the basis for selecting appropriately rated overcurrent protection devices. Secondly, understand that a UL listing doesn't automatically imply a fault current withstand rating. The absence of a specific fault current rating from the manufacturer necessitates a deeper evaluation of the equipment's suitability for the installation. Thirdly, recognize the AHJ role in interpreting and enforcing the NEC, but be prepared to discuss and clarify interpretations that may seem overly conservative or impractical. Fourthly, series ratings of overcurrent protective devices can be used to achieve higher interrupting ratings, but they require careful coordination and documentation to ensure proper protection. Fifthly, consider the potential application of fault current requirements to other types of equipment in the building and ensure a consistent approach to electrical safety. Sixthly, when faced with conflicting interpretations or requirements, engage in open communication with the AHJ and seek clarification or alternative solutions that meet the intent of the NEC. Seventhly, consult with equipment manufacturers to obtain additional information on equipment withstand ratings, safety features, and potential risks associated with fault currents. Eighthly, implement additional protection measures, such as arc flash relays or current limiting fuses, when necessary to enhance electrical safety and mitigate potential hazards. Ninthly, document all calculations, equipment ratings, and protection measures to demonstrate compliance with the NEC and provide a clear record for future reference. Tenthly, stay informed about changes and updates to the NEC and industry standards to ensure that electrical installations meet the latest safety requirements and best practices. To elaborate further, understanding the intricacies of fault current calculations is paramount in electrical system design. Fault current, also known as short circuit current, is the excessive current that flows through a circuit during a fault condition such as a short circuit or ground fault. Accurate calculation of available fault current at various points in the electrical system is essential for selecting appropriately rated overcurrent protection devices, such as circuit breakers and fuses. The available fault current is influenced by several factors, including the utility source impedance, transformer impedance, conductor impedance, and motor contribution. Utility companies typically provide information on the available fault current to the service entrance, which serves as the starting point for fault current calculations. Transformer impedance is a critical parameter that affects the fault current magnitude. Lower transformer impedance results in higher fault current levels. Conductor impedance also plays a significant role, with longer and smaller conductors exhibiting higher impedance and limiting fault current. Motor contribution refers to the additional fault current supplied by motors during a fault condition. Motors act as generators during a fault and contribute to the overall fault current level. Fault current calculation should consider the contribution of all motors connected to the electrical system. There are several methods for calculating fault current, including the point-to-point method and the infinite bus method. The point-to-point method involves calculating the fault current at each point in the electrical system, taking into account the impedance of each component in the circuit. The infinite bus method assumes an infinite source impedance and simplifies the fault current calculations. Software tools are available to assist with fault current calculations, providing accurate and efficient results. These tools typically incorporate component libraries, fault scenarios, and calculation algorithms to streamline the process. Proper fault current calculations are essential for ensuring the safety and reliability of electrical systems. Underestimating the available fault current can lead to inadequate overcurrent protection and potential equipment damage or failure. Overestimating the available fault current can result in unnecessary costs and oversized equipment. Therefore, it is crucial to perform accurate fault current calculations and select overcurrent protection devices with appropriate interrupting ratings. In addition to fault current calculations, understanding the role of UL listings and equipment withstand ratings is critical for electrical safety. A UL listing indicates that a product has been tested and certified by Underwriters Laboratories, a recognized safety organization. UL-listed products meet specific safety standards and are suitable for use in their intended applications. However, a UL listing does not automatically guarantee that a product is rated for a specific fault current. Some products may be UL listed for general safety requirements but not specifically tested for fault current withstand. Equipment withstand rating refers to the ability of equipment to withstand the effects of a fault current without causing damage or failure. Equipment with a withstand rating is designed and tested to withstand a specific level of fault current for a defined duration. Manufacturers typically specify the withstand rating of equipment in terms of its interrupting rating, which is the maximum fault current that the equipment can safely interrupt. When selecting equipment for electrical installations, it is essential to consider both the UL listing and the equipment withstand rating. Equipment should be UL listed for its intended application and have a withstand rating equal to or greater than the available fault current at the point of installation. If equipment lacks a specific withstand rating, it is necessary to evaluate its suitability for the installation based on other factors such as its construction, materials, and design. In some cases, additional protection measures, such as current limiting fuses or surge protective devices, may be required to protect equipment that lacks a sufficient withstand rating. Furthermore, recognizing the AHJ role in interpreting and enforcing the NEC is crucial for compliance and safety. The AHJ is the authority responsible for interpreting and enforcing the NEC and other applicable codes and standards. The AHJ may be a local building inspector, electrical inspector, or other qualified individual or organization. The AHJ interpretation of the NEC can vary depending on local conditions, industry practices, and personal judgment. Therefore, it is essential to establish a clear line of communication with the AHJ and seek clarification on any ambiguous or conflicting requirements. While the AHJ interpretation is generally binding, it is also important to advocate for interpretations that are consistent with the intent of the NEC and industry best practices. If an AHJ interpretation seems overly conservative or impractical, it is appropriate to discuss the issue with the AHJ and provide supporting documentation or evidence. In some cases, it may be necessary to appeal an AHJ decision to a higher authority, such as a court appeals board or a state electrical board. However, it is generally preferable to resolve disagreements through open communication and collaboration. It is also vital to understand the concept of series ratings of overcurrent protective devices, which can be utilized to achieve higher interrupting ratings. Series rating refers to the practice of using two or more overcurrent protective devices in series to achieve a higher interrupting rating than the individual devices would provide. When overcurrent protective devices are series rated, the upstream device is typically a high interrupting capacity fuse or circuit breaker, while the downstream device is a lower interrupting capacity circuit breaker. During a fault condition, the upstream device interrupts the fault current before the downstream device has a chance to operate. This allows the downstream device to be rated for a lower interrupting capacity, reducing costs and simplifying the installation. However, series ratings must be carefully coordinated and documented to ensure proper protection. The upstream and downstream devices must be tested and listed as a series combination by a recognized testing laboratory, such as UL. The series rating must be equal to or greater than the available fault current at the point of installation. The series rating must be clearly marked in the equipment and documented in the electrical system drawings and specifications. Series ratings should only be applied when the overcurrent protective devices are installed in accordance with the manufacturer's instructions and the NEC. In addition, it is important to consider the potential application of fault current requirements to other types of equipment in the building to maintain a consistent approach to electrical safety. Fault current requirements apply to all types of electrical equipment, including utilization equipment such as refrigeration equipment, HVAC equipment, elevators, and lighting systems. The AHJ interpretation of fault current requirements should be applied consistently to all types of equipment to ensure a uniform level of safety throughout the building. If the AHJ requires a specific fault current rating for one type of equipment, they should apply the same requirement to all other types of equipment in similar applications. Inconsistent application of fault current requirements can lead to confusion, non-compliance, and potential safety hazards. Therefore, it is essential to establish a clear and consistent approach to fault current protection for all electrical equipment in the building. Furthermore, open communication with the AHJ is essential for resolving conflicting interpretations or requirements and achieving compliance. Electrical codes and standards can be complex and subject to interpretation. When faced with conflicting interpretations or requirements, it is important to engage in open communication with the AHJ and seek clarification. Explain the basis for your interpretation and provide supporting documentation or evidence. Listen carefully to the AHJ explanation and try to understand their perspective. Work collaboratively with the AHJ to find a solution that meets the intent of the NEC and ensures the safety of the electrical installation. If necessary, consult with other experts, such as electrical engineers or code consultants, to obtain additional insights and perspectives. Document all communications with the AHJ and maintain a clear record of the agreed-upon interpretations and requirements. In addition to communication with the AHJ, consulting with equipment manufacturers can provide valuable information on equipment with stand ratings, safety features, and potential risks associated with fault currents. Equipment manufacturers are experts in their products and can provide detailed information on their performance characteristics, safety features, and limitations. Contact the manufacturer to obtain information on the equipment's withstand rating, interrupting rating, and other relevant specifications. Ask the manufacturer about any potential risks associated with fault currents and what measures can be taken to mitigate those risks. Obtain documentation from the manufacturer that supports the equipment's withstand rating and compliance with applicable safety standards. Share this information with the AHJ to support your interpretation of the code and demonstrate your commitment to safety. Moreover, implementing additional protection measures can enhance electrical safety and mitigate potential hazards. In some cases, additional protection measures may be necessary to protect equipment that lacks a sufficient withstand rating or to address specific safety concerns. Arc flash relays are devices that detect arc flash events and quickly de-energize the affected circuit, reducing the duration and severity of the arc flash. Current limiting fuses are fuses that limit the magnitude of the fault current, reducing the stress on equipment and improving system coordination. Surge protective devices, also known as SPD, protect equipment from voltage surges caused by lightning or switching events. Ground fault circuit interrupters, also known as GFCIs, protect personnel from electric shock by detecting ground faults and quickly de-energizing the circuit. These additional protection measures can significantly enhance electrical safety and reduce the risk of equipment damage, injury, or death. Finally, documenting all calculations, equipment ratings, and protection measures is essential for demonstrating compliance with the NEC and providing a clear record for future reference. Maintain accurate and up-to-date records of all fault current calculations, equipment ratings, overcurrent protection device settings, and other relevant information. Document the basis for all decisions and interpretations, including discussions with the AHA and equipment manufacturers. Keep copies of all documentation, including electrical system drawings, specifications, equipment manuals, and test reports. Store the documentation in a safe and accessible location for future reference. This documentation will be invaluable for demonstrating compliance with the NEC, troubleshooting electrical problems, and performing maintenance or upgrades to the electrical system. By following these guidelines and implementing a comprehensive approach to fault current protection, you can ensure the safety and reliability of electrical installations and protect people and property from the hazards of electrical faults. Staying informed about changes and updates to the NEC and industry standards is crucial for ensuring that electrical installations meet the latest safety requirements and best practices. The NEC is updated every 3 years, with significant changes and revisions to address emerging safety concerns and technological advancements. It is essential to stay informed about these changes and incorporate them into electrical system design and installation practices. Subscribe to industry publications, attend training courses, and participate in professional organizations to stay up to date on the latest developments in electrical safety. Review the NEC regularly and familiarize yourself with any changes that may affect your work. Consult with experienced electrical professionals and code experts to ensure that your electrical installations meet the latest safety requirements and best practices. By staying informed and proactive, you can contribute to a safer and more reliable electrical environment for everyone. Consider engaging with the AHJ to explain the limitations of equipment with stand ratings and the practicality of series rating. Explain to the AHA that equipment with stand ratings are not always readily available from manufacturers and that it may not be feasible or practical to require all equipment to have a specific withstand rating. Discuss the concept of series rating and how it can be used to achieve higher interrupting ratings without requiring all equipment to be fully rated for the available fault current. Provide the AHA with supporting documentation such as technical data sheets, test reports, and industry standards to support your arguments. Be prepared to answer the AHA questions and address any concerns they may have. The goal is to educate the AHA and persuade them that your approach to fault current protection meets the intent of the NEC and provides an acceptable level of safety. If the AHA remains unconvinced, consider providing additional protection measures such as arc flash relays or current limiting fuses. These additional protection measures can enhance electrical safety and mitigate potential hazards, even if the equipment is not fully rated for the available fault current. Arc flash relays can quickly de-energize the affected circuit during an arc flash event, reducing the duration and severity of the arc flash. Current limiting fuses can limit the magnitude of the fault current, reducing the stress on equipment and improving system coordination. By providing these additional protection measures, you can demonstrate your commitment to safety and address the AHA concerns. Contact the manufacturer of the refrigeration equipment to verify that the equipment meets all other applicable safety standards and to discuss any potential risks associated with fault currents. The manufacturer can provide valuable information on the equipment's design, construction, and performance characteristics. Ask the manufacturer about any potential risks associated with fault currents and what measures can be taken to mitigate those risks. Obtain documentation from the manufacturer that supports the equipment's compliance with applicable safety standards. Share this information with the AHA to support your interpretation of the code and demonstrate your commitment to safety. Remember that electrical safety is a shared responsibility and requires the cooperation of all stakeholders, including electrical engineers, contractors, OEMs, and equipment manufacturers. By working together and communicating effectively, you can ensure that electrical installations meet the highest standards of safety and reliability. To reiterate the importance of each point made, firstly, accurately calculating the available fault current at the point of termination to the equipment is non-negotiable. This calculation dictates the selection of appropriately rated overcurrent protection devices. Secondly, while a UL listing is valuable, it doesn't automatically imply a fault current withstand rating. This absence necessitates a deeper evaluation to ensure the equipment's suitability for the installation. Thirdly, the AHA plays a critical role in interpreting and enforcing the NEC. Open communication is key to address any interpretations that may appear overly conservative or impractical. Fourthly, series ratings of overcurrent protective devices can boost interrupting ratings, but this demands careful coordination and thorough documentation. Fifthly, extending fault current requirements to all equipment types in the building ensures a consistent and comprehensive approach to electrical safety. Sixthly, when conflicting interpretations arise, open dialogue with the AHA becomes essential for clarification and achieving solutions that align with the NEC intent. Seventhly, consulting with equipment manufacturers unveils crucial insights into equipment withstand ratings, safety features, and potential risks. Eighthly, adding extra layers of protection, like arc flash relays or current limiting fuses, significantly enhances electrical safety and mitigates potential hazards. Ninthly, meticulous documentation of calculations, equipment ratings, and protection measures showcases NEC compliance and serves as a valuable resource for future reference. Tenthly, continuously staying informed about NEC updates and industry standards guarantees that electrical installations adhere to the latest safety mandates and recommended practices. Finally, successful collaboration with the AHA requires explaining equipment withstand rating limitations and the practicality of series ratings, considering additional protection measures, and consulting with equipment manufacturers to ensure safe and compliant electrical installation. These steps ensure a robust and reliable electrical system.